welcome back. This time today we're going to start talking about the planet Mercury and the planet Venus. So we're going to do both of those, but I'm going to do it in two different sections. So we'll go through Mercury first, and then we'll go ahead and talk about Venus. Now, hopefully by now you've had a chance to pull down that document under Course Documents in Blackboard to go ahead and give you a summary of the characteristics of the planets. So I want you to have that there while we're looking at both Mercury, Venus, and the rest of the planets. So this is what Mercury looks like from space. Notice we don't get a whole lot of detail yet. And we're going to find out that there's a lot more detail once we have the chance to get a little bit closer. But we do know that as looking from space, Mercury is going to be really kind of grays and whites and some dark areas there. And I want you to picture the back side of the moon. And that's a real good picture of what Mercury is going to look like from space. It's very heavily cratered on a relatively smooth plane. Remember the other day we talked about how you can tell the age of the surface of the planet by looking at the number of craters? So we know that the surface of Mercury is extremely old because of the number of craters that are visible there. And we know that those craters came after that smooth surface, that plane that you're going to look at, because those craters are sitting on top of the plane. We also know that the surface of Mercury is going to show numerous crisscrossing because of the compression of what happens when the surface was in the process of shrinking. Mercury does not have any moons. So we're not going to find that we have too many moons until we get out to the Earth. So both Mercury nor does Venus have any moons. As I said, Mercury is extremely bright and can be seen either as a morning or as an evening star. It was recognized in ancient time actually to be the same, although sometimes you could see it in the morning and sometimes you could see it in the evening. Unfortunately, because it is so close to the sun, it does tend to get lost in the sun's glare. But one thing we did notice once we were able to observe Mercury through the telescope was that it did go through phases an awful lot like the moon, and that's because it's an inferior planet. And all that means is that planet is between us and the sun. So guys, how many inferior planets do we have? Well, hopefully you're going to tell me two. That's Mercury and Venus. So both of those will go through phases. Now let's talk about some general characteristics of Mercury. Like I said, number one, it was recognized from earlier times. It was named after the messengers of the god because of the fact that it rotates around the sun so quickly. It's closest planet to the sun, which would make sense then that it's going around the sun as quickly as what it is. It's also the smallest planet in the solar system. And it has, even though it's the smallest planet in the solar system, it has the second largest density, and its density is just right under that of the Earth's. So very, very close to the Earth, even though it's much, much smaller than what the Earth is. Because it's so close to the sun, it certainly has the shortest period of revolution. And because it is so close to the sun, remember Newton's law of universal gravity? Since it is so close to the sun, it does have the highest average orbital speed. It's got greater gravitational traction than between the sun and Mercury. It also has the largest eccentricity of any of the planets. Remember that eccentricity is basically how squashed that ellipse is. Now it does have what's called a weird rotation. I know, it's a really good scientific term, right? Weird rotation. But it does. It seems to rotate on its axis 3 times for every 2 times that it actually goes around the sun. And so its day, what we consider its day, is about 176 of our days, while its year is about 88 of our regular days. So you can see that it's got its day that's longer than its year. So it does have some issues, and we'll talk about exactly why it has that rotation a little bit later. Like I said, part of this is due to the large eccentricity, and then part of it is just due to the fact that it is as close to the sun as what it is, and there seems to be some kind of connection then between what's going on with Mercury's orbit and then the sun itself. Now I've got a little video I want to show you here that'll take just a couple of minutes to show you what it would look like on the surface of Mercury looking at the sun, and you'll find out that because of that effect there, it's going to look very different than what it looks like when we look at the sun on the Earth. Also, we're going to find out that Mercury has a tilt of its axis less than about 2 degrees. Now remember, the Earth's axis is tilted about 24 degrees. We're going to find out that Mercury has a very, very small tilt. So it does some weird things when you go ahead and look at the sun. So let's look at that here for just a second. Okay, now that you've had a chance to see what that looks like, it's kind of be a strange day on Mercury there. Let's look at what Mercury looks like in the sky. You have a picture here. You can see somebody over there on the lower right looking up with a pair of binoculars, and he's looking at the moon. And then over on the other side, you have 3 different planets. Now, 2 of them are pretty easy to see, but look at Mercury all the way down there in that twilight, that kind of orangish part right after the sunset. And so you can see that sometimes Mercury definitely gets lost in that little twilight area of the sun, but yet when we can see it, it is extremely bright. In fact, it's almost as bright as what Jupiter is. Here's another picture of the moon and Mercury is down there on the lower center part, just a little bit to the right. Now, one of the interesting things about Mercury when it gets down that low, and because it is so bright, then it's setting pretty quickly because it's following the sun itself. We are the Department of Physics, Astronomy, and Material Science, and so we always get calls right around that time because everybody thinks there's a UFO out in the sky. Because as Mercury itself goes down, it goes through a lot more atmosphere, and so that atmosphere tends to break up that light, and so it looks like you get some reds, some orange, yellows, greens, blues, all those kinds of things. And so people aren't normally used to seeing that there, and make these wild leaps of imagination. So we always get calls about UFOs when Mercury is visible, especially in the evening, because that's when a lot of people are out, not so much in the morning. Now, this is a picture of the sun, and what you see coming across the top, those little dotted lines, well, that's Mercury making a transit across the sun. It is hitting the upper center part of the sun. The little dark spot that you see right in the center of the sun is not Mercury. That happens to be a sunspot. Now, Mercury has some of the greatest temperature ranges of any of the planets in the solar system. It goes from about minus 300 degrees Fahrenheit up to about 800 degrees Fahrenheit. And so we have essentially the greatest temperature range on any planet. Now, we don't necessarily have the greatest temperature because we're going to find out Venus has a temperature greater than that of 800 degrees Fahrenheit. But Venus is very consistent in its temperature, where you have an extremely large temperature range on Mercury. We know that right at the equator, during the time that equator then is facing the sun, is when you get your highest temperatures. And then your lowest temperatures are right at the poles. And in fact, we think that it's cold enough that some of those areas have not been exposed to sunlight that we actually find ice on Mercury. So there's a hypothesis that ice is existing on Mercury. Now, in terms of the internal composition, remember I want to compare each one of our planets with what's going on within the Earth. Remember, Mercury is going to be a terrestrial planet, just like what Earth itself is. And so we kind of expect those terrestrial planets to have the same general characteristics. And then the only difference has to be either their position from the sun or what's been going on in the early part of the solar system to those individual planets. As I said, Mercury's density is slightly less than the Earth, and yet it's a much smaller body. So why would the density be as high? Well, think about what density is mass per unit volume. So I must have an extremely large mass relative to that volume to get that density as high as what it is. Well, think about the size of our moon. Okay? Think about the size of our moon. Well, I want you to put an object the size of our moon at the center of Mercury, and we think that that's Mercury's core. Because Mercury is smaller, the core has not been compressed nearly like what it has been with the Earth. And so it's extremely large. It's about 42% the size of Mercury. If we compare that with the Earth's core, it's only about 17% of the size of the Earth. So now you go ahead and take that core, the size of the moon, you put a small mantle on there, that interior part between the core and the crust, and then put an even thinner crust on it, and we think that that's what Mercury looks like inside. Now, obviously, we haven't had a way to be able to go ahead and check that by drilling down into Mercury, but we do have MESSENGER, which is one of the probes right now that's around Mercury. And one of the things that MESSENGER will try and do is answer some of the questions about why it has such a high density and what the core is like. Right now, we think that the core probably looks something like this. You can see that it's got an extremely thin crust on it. and that's the surface of Mercury. Then you can see the mantle area, that part in red, and then you have that really big orange part, which is the core itself. Now, we do know that Mercury has an extremely small magnetic field, but it does have a magnetic field. So it's not something that is just there part of the time. It is there. It's about 1.1% that of the Earth, which means it's relatively small. But now remember, think about why the Earth has a magnetic field. It has a magnetic field because of the molten core, that molten iron and nickel core for the Earth. So that means you must have some part of Mercury's core that is also molten, and it is also then rotating to be able to give it that magnetic field. We think that it is probably kept in motion by the strong tidal forces between Mercury and the Sun, as well as the fact that Mercury has this really high eccentricity. So some of the time it's closer to the Sun, some of the time it's further out. So we think that there's a reason why part of that core would still be molten. We also think because the planet itself is so small that it has cooled off, and that's why the rest of the core itself is not molten. Probably at one time it was. It is just over the years that it has indeed cooled off. We know it is strong enough to go ahead and trap solar wind plasma. So we know it is strong enough to go ahead and affect what's going on then on Mercury. We also know that there are magnetic tornadoes that form within that magnetic field, and it seems to allow then that magnetic field to get all the way down to the surface itself. So that magnetic field has somehow kind of moved away, which is allowing then these vortexes to get down to the surface. So there's still lots of things that we're not sure about what's going on Mercury or why, which is one of the reasons why we have sent Messenger back out there. So why does it have more iron than any other planet? Why is it not compressed? Probably not compressed because it's not large enough. But there are three leading hypotheses on why that core might be the way it is. So could it have originally been like the other terrestrial planets, but kept getting hit from all kinds of debris that was roaming around the early part of the solar system when it was being formed, and everything just kind of kept running into Mercury, and so therefore it got stripped away? And so what we are seeing is basically the core with a little part that was left on top after everything got basically stripped away. Okay. It also could have been the fact that it formed, because it was very, very close to when the Sun formed because of that distance, and just in the process of the Sun forming itself and undergoing some various things right before it settled down into the star that we know, did maybe we have the Sun go off and maybe strip off the outer parts of Mercury. So maybe it's not there simply because of the fact that the Sun's either solar winds or whatever happened at the beginning simply stripped it away. And then, same thing again, thinking then after the Sun was formed, did something happen with the early part of the solar nebula, the solar sun, when it was forming? You know, it's settled down now, and yet maybe something happened that caused it to blow that material away. So we're not really sure, basically. So that's one of the things, like I said, Messenger will go ahead and try and answer. And we know that kind of depending on what caused it, there will be different chemical reactions that affect what then the planet looks like. And so that will give us a feel if we can go in and look a little bit more at the chemical composition of Mercury to see what happened. So let's look at the surface itself. There's certainly larger basins that resemble the moon's seas. Remember those mares in both size and appearance, but not generally as dark as what we see on the moon. Also shows, again, a more heavily cratered surface than what the front side of the moon does, not the back side. So think the back side of the moon when we're talking about Mercury. Probably think that those craters form from both impact and volcanism. Now, guys, don't think of Mercury as having these big, gigantic volcanoes. Okay, those are not the kind of volcanism we're talking about. Think more like things ran into the surface, split the surface apart, that mantle is so close underneath there that then the lava just spilled out on the surface. More like some of the volcanoes that you would see or the lava flows that you would see on the Hawaiian Islands. So again, not the big ones, just where you have that lava that is spreading out on the surface. It seems like the surface has been geologically inactive for billions of years. Now, remember that we think that the solar system itself is about 4.5 billion years old. We know that at the first part, that new part of the solar system during the time that it was settling down after initial formation, that there were lots of things going through the solar system. Okay, things ran into each other. Okay, things settled down, and then it seemed like things were relatively quiet until about a little bit more than about 3.8 billion years ago. And something happened, it seems like, so that the surface was extremely active at that time. So was there something going on? And we see that not only on Mercury, but some other planets as well. And then, after about 3.8 billion years ago, it seems to have quieted down. Not very much going on. So not exactly sure, since we weren't back there about 3.8 billion years ago, to really see what was happening. So we also know the surface has undergone weathering and erosion from the solar winds, things like that. There is still meteorites that will impact the surface, which are going to help with the weathering as well. We also know that the surface shows numerous compression folds. And remember, Mercury is smaller. It's been cooling off, and so we think that as that surface cooled off, then the surface shrunk, and the way that you're getting those wrinkling or those compression folds which crisscross the planes is because of the shrinkage of the surface itself. Okay? Like I said, probably because as Mercury cooled, it's smaller, so it couldn't retain its heat nearly as well as what it could if it was something like Venus or the size of the Earth. It's also flexible simply by the fact that you have these tidal bulges that are there from the sun. And these tidal bulges are about 17% larger than what the moon's pull is on the Earth. And when we look at Mercury, remember I said Mercury was extremely bright? Well, that's because you have a very high albedo, and it's that amount of reflectivity on Mercury. And we think that that's probably due to young craters. So you have a crater that is formed, something is impacting it, and it sends these rays out. Well, those rays then are newer material than what you have already on the surface, which has undergone weathering and erosion, and so they show up very well. So part of that, we think, is looking at that material that has been brought up from a little bit underneath. But also there's some evidence, like I said, that there is this water ice at the bottom of the craters, and so that's the other reason that we're seeing some very bright spots, is we're seeing the reflection of ice from the sun. And this is a picture taken on the North Pole, and you can see some of the areas that are lighter there that we think may be that ice that we're seeing being reflected. So we have these very long cliffs, these scarps, things like that, because of that cooling. And I'm going to show you some of these here in just a minute. Now, there's a very large basin on Mercury called Caloris Basin. And I'm going to show you a picture of that, and then what we think happened is something came in, hit that. Well, it hit it so that it was large enough that it sent shock waves all the way around the surface. And right directly, 180 degrees on the other side of the planet, we have what's called weird terrain. Well, it's terrain that looks like something just completely jumbled it up. And we think it's where those shock waves that came out from this original impact then went around and met on the other side and just basically jumbled that material out. And so this is what that very large basin looks like. Now, I need to immediately tell you guys that the color that you're seeing right there is false color. Okay? That color is there to bring out the difference in composition. Okay? It's not really blues and yellows, although it's kind of a cool color looking at that, but that's just false color. But it shows you then the basin right here, and like I said, directly 180 degrees away from that on the other side of the planet, you get this terrain that looks like it's been simply jumbled up. And it's probably because when that thing hit, it certainly caused a huge shock wave that was felt all the way around that planet. Now, Mercury doesn't have an atmosphere the way that we normally think of an atmosphere. Okay? But it does have a really thin atmosphere that's there because of the fact that you have the solar winds running into it. You have other things running into it that are going to go ahead and basically form then this atmosphere of particles that are being ejected from something running into the surface of Mercury. So it's got all kinds of things that we didn't expect. We've got molecular oxygen, we've got sodium, we've got hydrogen, helium, potassium, magnesium. There's also a number of other chemicals, including some water-related ions, which is where we're coming up with the idea that there has to be water someplace. Now, think about other things that will fly through the solar system. We haven't talked yet about comets, but we certainly will. And so we feel like comets have also run into the surface of Mercury, and that might be one way that you have some of those water-related ions that are there in the atmosphere. It's not any kind of atmosphere, like I said, in the form that we would think of being able to breathe. It is just very, very transparent, very, very thin, but it is there because Mercury has got enough mass, enough gravitational attraction to go ahead and hold it in. Now, it also, because of where it is and how it is made, it is not stable at all. So it is continually leaking off into the atmosphere, or leaking off into outer space. And like I said, it's probably there because of that decomposition as you have things running into the surface. I mean, we've got a lot of energy coming in from that sun. So that sun can go ahead and decompose some chemicals very easily because of the amount of energy that's contained in those electromagnetic radiation waves. So like I said, continually leaking off, sins to be formed, things like that. Now, how do we know this? Well, we have been visited twice by two different probes. The first one went up in about 1974. That's when we were really starting to send the probes out to some of the planets to get a feel for what's going on. And so Mariner 10 visited Mercury in 1974, and it photographed about 45% of the surface. So a lot of the original photographs that we had of Mercury we got from Mariner 10. And it gave us that idea that Mercury basically looked like the backside of the moon. Well, that really didn't answer, though, a lot of our questions. And so we sent Messenger out, and there are two pictures that are superimposed right here. The light that you see in the back basically is Messenger taking off from the Cape, and then in the lower right-hand side then is what Messenger looks like. Now, Messenger is in orbit around Mercury as of 2011, so it's finally settled down and was put into insertion of orbit in March of 2011. However, notice that it was launched in 2004. Okay, well, where did it go from 2004 to 2011? Well, it did go ahead and do a series of flybys. It went by the Earth, took lots of pictures and collected some data. It went by Venus a couple of times, and went by Mercury, came back around then, every time recording large amounts of data, and then, like I said, finally settled down in orbit in 2011. So they're there to go ahead and try and answer some of the questions that we have about Mercury. Number one, where does it have that high density from? We think we know, but those are just hypotheses. We're not really sure. We really would like to know what's going on with Mercury and what's really going on inside the core. And granted, we can't get out there because it's not landing, so we're not drilling down. So we have to use other techniques to be able to let us figure out what's going on within the core of Mercury. And not only what's going on within the core, well then how does that affect Mercury's geological history? How does that affect the nature of Mercury's magnetic field? Is it there simply because of the fact that Mercury still does have some of that core that's molten? Will we be able to tell that? Will we be able to see if there's maybe something else going on? We also want to know about that structure. Is it got an inner core? Is it an outer core? I mean, we know the Earth has an inner and outer core. We assume that the terrestrial planets formed in basically the same way. Maybe that mantle in the crust, is doing something differently than what we expected. So that's one of the things that we want to look at is what's going on with that core and everything else that exists because of that core. Certainly, is there any ice on Mercury? At one time we thought that water ice was very unique to the Earth. We've now come to the conclusion it's not nearly as unique as what we thought it was. Is that still there? Can we get better pictures of it? Can we figure out if it's other places other than just the poles? And then, going back to the idea of where did Mercury's atmosphere come from? Okay? Is there some other mechanism that we're not aware of that we'll be able to kind of see what's going on there? And so these are questions that Messenger is designed to answer. It's expected to be there for a number of years and send back data. So hopefully within the next several years, by, let's say, 2014, 2015, something like that, we should have some much better answers than what we do now. And so even though this is 2011 right now, hopefully by 2015, something like that, we'll have much better answers and certainly more definitive answers on what's going on within Mercury. So now let's go look at Mercury. Certainly looks like the backside of the moon to me. You can see that very heavily cratered. Now realize, guys, you're seeing lots of little squares in that picture, and that's because of the way the picture was put together. There's not really all those nice little squares on Mercury to go ahead and show up like that. Notice you get some very nice bright spots. We think those bright spots, or the lighter spots, are probably from newly formed craters. Now, remember that I said it hadn't been geologically active for about 3.8 billion years. There's a difference between being geologically active and having impact craters. Those impact craters can happen. That geologically active part talks about what might have been going on within the core itself and the mantle, and the lava then that was being produced, and what would happen if something smashed into the planet and you had that lava then that kind of came up because of the collapsing crust there. So we can still have impact craters, probably not as many as what was during the original formation of the solar system, but we still do think they occur, and we see here evidence the fact that these are probably younger craters than what some of the other craters are on Mercury. Remember some of those large scarps-and cliffs that I talked about that kind of crisscross the planet? That's kind of what you're seeing here. Just think of a tablecloth, and you're kind of pushing it together. Okay, and those areas will be uplifted where you're getting the creases and the folds in the tablecloth. That's exactly what we think happened to Mercury. And you can see down there on the lower right that there's a relatively large crater that looks like it has these nice fresh rays coming out of it, as well as some other nice bright spots on there. Just going to go through a series. Now these two pictures, again, are falsely colored. And they're there to kind of show the surface of Mercury and try and pick out the different characteristics and different compositions. Because one of the things that is kind of strange about Mercury is that the surface itself is not homogeneous. It is very heterogeneous. It is very different all the way through. And so we've got to try and figure out exactly why it has that different composition. And then, of course, you can see the big basin right there on the one on the right, and then even to the right of that. Some of the plains, remember the plains we think formed first, and then the craters then came on top. And we have two different kinds of plains. Okay, you can see the plains that are actually behind the craters, and they're one construction or composition. And then we have the plains that are formed inside those craters. Probably the ones that formed inside the craters could either have been liquefied when whatever meteorite hit, or forming from something else. But they do seem to be two distinct characteristics. Just kind of showing you some different images of Mercury to kind of give you a feel for what the surface looks like. And as you look at these, remember that the craters, the number of craters, the craters are sitting on top of something. They probably came last. Those light areas are probably areas that are a little bit younger. Also, as you're looking at these, how would you go ahead and answer some of those questions about how those craters formed and where they're from? You can see some of the little mountain ranges that are probably from ejected material when the crater formed. Some of those craters formed from material running directly into Mercury from above. Some of them, when the craters were formed, came in from material kind of hitting in a sideways glance. So you have the different shapes of the craters. And you have craters within craters, large craters and small craters. And you get some really bright areas right here. Exactly what's going on? Could be lighter material, but some cases we're not exactly sure. Lots of mysteries still out there to be solved. Another example of lighter areas, it doesn't exactly seem to be coming from looking at rays, so is it that material that came in and hit kind of at an angle and then was given off or ejected? But it's definitely different material than what you see the areas around it. This one definitely gives you a feel for a crater that was formed from impact, then material then that was spewed up and spread out when it hit. Eventually that will all turn to a darker color as that surface gets weathered and erosion from the solar winds, things like that, as well as just from micrometeorites hitting it. We'll get an example of craters within craters. And in this one, you even get more craters within craters within craters. This is one of the larger craters on Mercury. And you can certainly see that there are some craters within that plane, within the center of the crater, but not an awful lot. And so this is one way then you can determine the age of the original crater simply because of the number of smaller craters that are inside it. So this is a very useful technique. False color here to go ahead and bring out the different characteristics and composition. Very flat right there. So something came in and hit and basically went ahead and either filled in from lava or went ahead and melted and filled it in because of that, but certainly very flat. And notice the lack of craters in the center here. So with that, guys, I just wanted to give you a feel for Mercury, how Mercury compares to the rest of the planets. We're going to head from here now out to Venus, the next planet out, and we'll find Venus is incredibly different than what we just saw on Mercury. So with that, guys, I'll see you next time when we talk about Venus.